So looking at the large intestine, so it's called the large intestine, not because it's longer than the small intestine, because it's actually not longer than the small intestine. It's only about 5 feet long. It's called the large intestine because of the diameter is a lot larger than the small intestine. As you can see, if you take a look at the picture, and if you look at the one that's comparing it to the small intestine in the book, you can see how large it is. So some of the main functions here is going to be absorbing water. So yes, we absorbed a lot of water in the small intestine, but we need to make sure that we absorb the rest of the water here in the large intestine. Also electrolytes, some things like sodium and chloride are going to be absorbed here as well. After that, we are going to start to compact it into feces. And then, of course, we'll talk about how the rectum is going to store it until it's ready to be eliminated for defecation. So let's take a look at a little bit of the anatomy of a large intestine. So the very first part is going to be the cecum. So this says it's the ascending colon, which is not good at all. So the ascending colon is here. Bad picture. I need to take this off. And this is going to be the cecum here. So the cecum is going to be that very first part that is going to join the ileum. So we have the small intestine at the very end of the ileum that is going to empty its contents into the cecum. And you do have that ileocecal valve that's going to be found here that's going to regulate what's going from the ileum into the cecum. It's a very small part here. But still, that's really bad that they labeled this as the ascending colon. So that's why you shouldn't trust anything on the internet, right? So from that cecum, you're going to go up the ascending colon. It's going to go across the transverse colon, and it's going to go down the descending colon. There's that sigmoid colon, and then we are going to have the rectum at the very end portion there. So the three main parts of the large intestine are going to be the cecum, the colon, and the rectum. You also have that little tiny vermiform appendix. It's going to be right here. It's going to be lined with lymphatic nodules. It's something that we can live without. So I mean, some scientists will probably slap me in the face for saying that it's just, a vestigial organ that our body really doesn't have to have. If we take a look at some of the little structures here, I like this picture a little bit better. It doesn't bother me as much that it's the other one's mislabeled. So if we take a look at some of the structures, you can see how it forms these little pockets right here. These are called haustra. Let me write that down if my pen wants to work. So these are called haustra. So we'll talk about how important that is to form these little pockets. So we are able to go in and form that feces, and it's allowed to expand or able to expand because of that as well. So now let's take a look at these bands of smooth muscle that are running the length. Here you can see them right here on that large intestine. So what these are called tinea coli, and I might be spelling it differently. I've seen it spelled a couple of different ways, so I apologize if I'm spelling a little bit different than the book. Sometimes I've seen an A written in here, but those are going to be important. We'll talk about the importance of these in the defecation reflex. So moving on away from that bad picture. All right, so let's take a look at the very end portion of the large intestine, which is going to be the rectum here. So the rectum is mainly going to be, it's a muscular organ, as you can see all of the muscle that's surrounding it, and it is also going to be an expandable organ because of the fact that it expands whenever we store feces here. So if we specifically take a look at the very end portion of the rectum, this is going to be where we have the anal canal. So there's a few things here. So of course the anal canal is going to be lined with stratified squamous epithelium. If you think about what stratified squamous epithelium is for, it is going to be important for, of course, protection. And since this is where defecation occurs, then that is going to be why we need that stratified squamous epithelium here. We are also going to have, as you can see here, these little anal sinuses and columns. These little rectal valves, you actually have about 3 of these rectal valves. These are actually quite important. This is going to allow you to pass gas without actually defecating on yourself whenever you pass gas. So these are quite important valves there. So if we didn't have them, then things would be really uncomfortable all the time. And at the very end, as you can see, we have a couple of new sphincters here. These are going to be very similar to the urethral sphincters that we introduced in the urinary chapter, except these are going to be the internal anal sphincter and the external anal sphincter. So remember how one was going to be smooth muscle and the other one was skeletal, which meant one was involuntary and one was voluntary. These are going to follow the same kind of pattern. So your internal anal sphincter is going to be the one that's involuntary and it's going to be smooth muscle. That's going to be the one right in here at the base of the anal canal, all of this right here. So we'll talk about the importance of this and the defecation reflex at the end of this section. And then here is the external anal sphincter here. This is going to be the one that you are going to have control over, skeletal muscle. This is going to be the one that if you're not ready to defecate, then you have control over it and you can go in and contract those muscles and keep the feces inside of that rectum or that anal canal. All right, so as far as appendicitis, the name tells you exactly what it is, the inflammation of the appendix. And a lot of times it can be because you have fecal matter that's obstructing the appendix. Eventually that appendix, of course, since it's inflamed, it swells up. There's no blood supply getting to it. The bacteria start to overgrow. And if it's not treated, then it can rupture. And that is extremely dangerous because that can cause peritonitis, which is going to be inflammation of that peritoneal cavity. The way that an individual knows that they're having an attack, an appendicitis, is going to be if they have pain in the right lower quadrant. So because if you think about where that appendix is, it is going to be in that right lower quadrant there. But you typically will have fever with it, nausea, vomiting, and then of course tenderness in that area as well. And this is very treatable and very easy to live without your appendix. So surgically remove. It's called an appendectomy. Let's take a look at the histology of the large intestine. So it's going to be quite different than the small intestine in the fact that there's not going to be any villi. There's not going to be any plica here. Remember that caused surface area. We really don't need it here in the large intestine. What we need is going to be something a little bit different. And that's kind of what the haustra is giving there. What we have here is going to be lots of goblet cells. And intestinal glands, and their main function is to secrete mucus. They secrete that mucin, and the mucin is going to, of course, combine with water, and that is going to be, of course, where mucus is going to be formed. You also are going to have lymphatic nodules. You can see them down here in the lamina propria. So again, more protection, as you can see. So the mucus is going to be really important to make sure that we secrete lots of that, as it's going to help lubricate the feces and allow for passage. So we'll take a look and see at the very end with the defecation reflex and how you do have some very important glands at the very end of the rectum that are going to help with passage as well. So another interesting thing about the large intestine is going to be that we have something called a normal bacterial flora or an indigenous microbiota. Indigenous meaning that they are going to be found, they are going to be living right in there in the large intestine. They're going to be found and located there. The most common of the flora is going to be E. coli, but we actually have lots and lots and lots of different species of bacterial, even genus and species of bacteria living in the gut. And these are actually very important. They've linked lack of bacteria to a lot of different things like obesity, Crohn's disease, and things like that. So it's really interesting how it's really important to make sure that you do have a healthy gut bacteria. So some of the things that the bacteria are going to do is they are going to break down carbohydrates, proteins, and lipids, but specifically a carbohydrate that we can't break down, which is cellulose. So they are going to be really important in breaking down things like lettuce and plant cell walls and things like that. So we'll talk more about that later on. Also, they produce carbon dioxide, they produce hydrogen ions, they produce hydrogen sulfide and methane. So as you can see, those hydrogen, if you know what hydrogen sulfide and methane is, it's a very odorous gas. So a lot of times bacteria are going to give rise to some of the more odorous gas that you produce every now and then. And also another thing that's really important is they produce B vitamins and vitamin K as well. So yes, we can get those in our diet, but it's really great to know that the bacteria in our gut produces these as well. So once they produce them, we're able to absorb them in the large intestine. When we eat them in our diet, the small intestine actually absorbs them. But it's great that the large intestine can absorb some things, because if you think about it, we really don't have a lot of things that we're absorbing here in the large intestine because most of the stuff has already been absorbed by now.